This lesson is based on the laws of logarithms, and we have three laws written here. That the log of any base of b times c is the same as the log of b plus the log of c. The log of any base of b divided by c will be the same as the log of b minus the log of c. And the log of b raised to the power of n will be the same as n multiplied by the log of b. Now let's look at each of those laws one by one and explain how those laws came about. Let's make x the log of b and y the log of c. Changing that into index form, we have a to the x is equal to b and a to the y will be equal to c. So if we multiply b by c, in fact, we are multiplying a to the x by a to the y. And as our laws of indices tell us, if we have the same base, we add the indices. So BC will be the same as a to the x plus y. Now let's rewrite this equation that is in index form into our logarithmic form. So the logarithm will be x plus y. X plus y will be log, the base is a, of BC. And remember that x is log base a of b, and y is log base a of c. So when we add x and y together, we have this law being written out, that when you multiply b times c and take the log of it, it is the same as the log of b plus the log of c. Log of PQ, applying this law of indices, can be written as the log of p plus the log of q. The log of q plus the log of r can be written as one single logarithm being the log of qr. So two logs added together to form one single logarithm. How do we write the log of 15 as the sum of two separate logarithms? Let's first find factors of 15. So we could start with 15 and 1. So this could be written as the log of 1 plus the log of 15. Now we wouldn't write it as that because if you remember from our previous video that this here is actually equal to 0. So this would not make sense. So instead, let's write it as the log of 3 plus the log of 5. Why? Because 3 times 5 gives us 15. Now let's look at our second rule. And we use the same proof here. We make x equal to log b and y equal to log c. And again, in index form, this is the same as a to the x power being equal to b and a to the y power being equal to c. Now, if we divide b by c, we're actually dividing a to the x by a to the y. And when we divide indices that are of the same base, we subtract the powers as we see here. Now, putting this equation into logarithmic form, we get a statement with x minus y being the answer. So x minus y is actually equal to the log base a of b divided by c. And remembering that x is log b and y is log c, we end up with our rule that the log of b divided by c is actually log b minus log c. Now let's apply it in a few examples. Again, quite easy. Log of p divided by q is log of p minus the log of q. So one logarithm expanded to two separate logarithms. What about the log of pq divided by r? If we look closely, we're actually going to apply two rules of logarithm because in the numerator, p is multiplied by q, and in the denominator, pq is divided by r. So first, let us write this in the form of two logs where we have the numerator, which is pq, minus the log of the denominator, which is r. And log pq can be written as log p plus log Q minus log R. Now we have log Q minus log R, two separate logarithms, and you want to write it as one logarithm. This would be the log of Q divided by R. Now let's look at our third logarithm, which has log base A of B raised to another power. So you have a logarithm of something being raised to a power. And that rule says you take the power that it is being raised to and you simply multiply it by the logarithm. So to prove this, it is slightly different. So we just have x being equal to log base A of b to the n, because you only have one statement here. Now if we write that in index form, the base is A, so A raised to the x power is equal to b to the n. Now A to the x divided by n is equal to b. And just in case you do not understand what just happened there, what we try to do is make b the subject. So we have b to the n, and we're going to find the n root. And if we find the n root of this side, we have to find the n root of the other side. So this in index form will be a to the x over n being equal to b. So that's how we got this here. Writing this in logarithmic form, you have your base being a, which is here, is equal to b, which is here, and that is equal to your index, which is x over n. And now we want to make x the subject, so we transpose and we get x being equal to n times log a b. So n is multiplied by log base ab to get x. And x was log a of b to the n, so this gives us our third rule. So let's apply everything we've learned so far. So we have log of p to the nth power times q. So now we see we have two laws being applied. You have p to the nth power, so that will be raising a number to the power, and p to the nth power is multiplied by q. So we're going to add two laws, the first law and the third law. So let's do that. We apply the first law, which is log of p to the n power plus log of q. Okay? And then log of p to the n power is the same as n log p plus log q. We didn't do the power rule first because that power n is only applied to p. Another example, we have the natural log, which is just like any other log, it's just that the base is different, of x squared minus 1. X squared minus 1 is a difference of two squares. I hope we all remember that from our algebra. So the natural log of x plus 1 times x minus 1. This is what this is equal to. So this becomes the natural log of, applying our first rule, where you multiply them, it would be the natural log of x plus 1 plus the natural log of x minus 1. Now we cannot distribute it, we cannot do those things because natural log is not a number. Okay, so therefore this is the simplest way we could write it. Another example is we have the log of the square root of p over q. Now square root in index form is actually 1/2. So square root means you have raised something to the power of a half. So let us rewrite the log of p divided by q, but instead we raise it to the power of 1/2. So this is actually a half of the log of p divided by q. Now the log of p divided by q we put a bracket, is the log of p minus the log of q. Now if a half is multiplied to each thing here, it becomes log of p minus a half the log of q. And here we have it. Now we have two things to simplify, two things to expand. So let's just do that. We have 5 log x minus log y. So we're simplifying. Or in other words, we're going to rewrite this into a single logarithm. So 5 log x is the same as log x to the 5th, and this is subtracting log y. Using our second law, this becomes log x to the 5th divided by y. Another example, we have log x plus a half log y. So log x stays as is, but we can apply one of the laws to the second one. So that would be log y to the 1/2 power, which is the square root of y. So this becomes log x times the square root of y. Now we're asked to expand. Expanding meaning you write it as a sum or difference of logarithms. So we have log 2 times the square root of x. So since we're multiplying 2 by the square root of x, this can be expanded to log of 2 plus log the square root of x. Now the square root of x can be further expanded or rewritten, I should say, to the log of 2 plus 1/2 log x, because the square root of x is x raised to the 1/2 power. And the last one, we have 5 log x squared y over z cubed. So the 5 that is multiplied becomes the power of whatever we're taking the log of. So this becomes log, open bracket, x squared y over z cubed. And this is raised to the 5th power. So let's apply our laws of indices to simplify what's in here. The log of x, so when we raise a power to a power, it's multiplied. So x to the 10, y to the 5th, divided by z to the 3/5 are 15 power. So this becomes log of x to the 10, y to the 5, minus log of z to the 15. And this can further be expanded to log of x to the 10th power plus the log of y to the 5th power minus the log z to the 15th power. So this becomes 10 log x plus 5 log y minus 15 log z. And there you have it. These are the laws of logarithms. So we have 3 laws of logarithms that I would suggest you memorize, because we're going to use them whenever we work with exponents or whenever we work with logarithms.